A uniform rope of length L and mass m1 hangs vertically from a rigid support. A block of mass m2 is attached to the free end of the rope. Let me draw the diagram here for the given data. One rigid support is there. Assume this is the rigid support. And for this one rope is attached. This rope mass is m1. And at the end of the rope, one mass m2 weight 8 is freely suspended. The transverse plus of wavelength lambda 1 is produced at the lower end of the rope. That means from here, from the lower end of the rope, one transverse wave it is produced and it is lambda 1. Lower end of the rope, the wavelength of the pulse when it reaches the top of the rope, it is lambda 2. So here it is lambda 2. The ratio of the lambda 2 divided by lambda 1, we need to find here. Okay, since here, this is the M1 and this is the M2, then the tension at the M2, it is equal to, T1 is equal to M2 into G, and at the top, here, the tension is T2 is equal to M1 plus M2 into G here. G. We know here the mu value. Mu is equal to, we can find as mu is equal to m by L here. Right, that is m1 by L here. Right. Then, since we know that a wave is produced, its frequency will not change, but the velocity and the wavelength, that is the lambda value, will changes. Then the velocity we can write as v is equal to under root of t divided by k, which is nothing but frequency into lambda. With respect to the 1, v1 is equal to f into lambda 1. With respect to v2 is equal to f into lambda 2. Then we can take the lambda 1 by lambda 2, which is equal to v1 by v2. Then we can write in terms of division under root of t1 by t2. Then I can write the value, that is m2 divided by m1 plus m2. This is the value of lambda 1 by lambda 2. But there is in the ratio of lambda 2 by lambda 1, that is lambda 2 divided by lambda 1 is equal to under root of, it is reciprocal just, that is here m1 plus m2 divided by m2. So option B is the right answer here.